Hello everyone, today's video is on the real number properties, as you can see. So you might have seen some of these properties in the past, but we need to review them and go over them before we get into our equations unit. So the first property is the commutative property. If you want to underline CO, that's kind of like a little trick to remember. And I want you to write down change order. The commutative property, all you're doing is you're changing the order. So what we're going to do with these examples is we're going to do one example with shapes, one example with letters or variables, and one example with numbers. So the commutative property of addition and the commutative property of multiplication are similar. It's just one has to do with addition and the other has to do with multiplication. So I just want you to write these examples down. So this first one, we're going to use shapes. So if we have a circle plus a square, that is the same thing as saying a square plus a circle. If we move on to the variables, if we have a plus b, and we change that order to b plus a, we are still going to get the same answer. And that should be pretty obvious here once we use these number examples. 5 plus 3 is the same thing as 3 plus 5. If you change the order, it's still going to say the same. Same thing with multiplication. If we have a triangle times a rectangle or a stick, whatever you want to call it, that is the same thing if we just change the order and we flipped them and we did a stick times a triangle. Moving on to the variables, a times b is the same thing as b times a. The order is just changed. And finally, if we put some numbers out there, 4 times 2 is 8, obviously. That is the same thing as 2 times 4, which is also 8. So the commutative property is changing the order. Moving on to the associative property. This is the property with the parentheses, if you want to think of it that way. You're changing what's inside the parentheses. So first example, we're going to have some shapes again. If we have a triangle plus a heart plus a circle, I'm going to erase that because I need to write a little bit smaller, but you can keep it on your paper. If we have a triangle plus a heart, inside parentheses plus a circle, that is the same thing as if we had in parentheses a circle plus a triangle, for example, in parentheses plus a heart. If we move on to an example with variables, if we have a plus b in the parentheses and then plus c on the outside, that is going to be the same. We're going to get the same answer as if we just kind of shifted around what's in the parentheses. And now we had b plus c in parentheses. Hopefully you can see it a little bit more clearly in this number example. If we have 4 plus 5 in parentheses plus 7 outside, that is going to be the same thing as if we shifted around what's inside. Say we put 5 plus 7 inside. So the top example, we're going to have 9 plus 7, remember GEMDAS. Got to do what's inside the parentheses first. On the bottom, 5 plus 7 is 12, and then 4 plus 12 is also 16. So the associative property is just taking the same numbers. It's going to be the same numbers, in the different problems, but we're shifting around the parentheses and shifting around what's inside of it. Moving on to the associative property, it is the same thing, except now we are going to use multiplication signs because it's the associative property of multiplication. So again, I'm just kind of shifting around what is inside the parentheses. It's the same variables, it's the same numbers, it's the same order, we're just kind of shifting what is in the parentheses. So my last example here with numbers, I'm going to do it in green. If we have 3 times 2 in parentheses times 9 outside, that is the same as doing 3 times and then in parentheses 2 times 9. So at the top we would have 3 times 2, which is 6, and then 6 times 9 is 54. On the bottom here, 2 times 9 is 18, and 18 times 3 is also 54. So commutative property, the one at the top, that is changing order. You're just flipping around the order. Associative property, we're not changing the order, but we're changing what's inside of the parentheses. And then finally, the distributive property, this is the one where we are taking something outside of a parentheses. So for example, like a circle, if we multiply a circle times a square plus a triangle, you might have seen these little, I call them jumps or whatever. You might have seen those lines before. That's just telling you you need to multiply the circle times the square, which gives you circle times square. Whoops, it should be a plus sign. Plus the circle times the heart. So you're taking whatever is outside the parentheses and multiplying it by everything inside. So A times B is just AB, plus A times C is AC. We could also do this with subtraction. So that would be AB minus AC. And then finally, the example with numbers. Here's my example, 3 times 4 plus 1. If we distributed that, that would be 3 times 4 plus 3 times 1. We could also do something with subtraction. So that right there would be 2 times 5 minus 2, times 3. And now obviously we would want to simplify that in a real problem, but that is the distributive property. So we should be on the back of our notes page now. The next property, there's 3 more. The next one is going to be the identity property. So the way I like to think about this one is you are either adding or multiplying a number that doesn't change its identity. The identity is still the same. So the number or the variable or the shape is still the same. So if we start with a little heart here, think about to yourself, okay, what can I add to anything where it doesn't change the value? Well, that's 0. Anything plus 0 is itself. So I'm not changing the identity there. So A plus 0 equals A. My number example is negative 7 plus 0 is still negative 7. So whenever we have the additive identity property, that's just saying, okay, anything plus 0 is itself. The identity has not changed. Whoops, sorry, that should be a multiplication sign. All right, so for the multiplicative identity, you're thinking to yourself, okay, what can I multiply by? What number can I multiply anything by so it doesn't change its identity? Well, anything times 1 is going to be itself. So star times 1 is star, A times 1 is still A, and then a number example, 14 times 1 is still 14. So for the identity property, you are trying to either add or multiply a number so it doesn't change its identity. Inverse. A good way to think about inverse is opposite. So I suggest you write that down on your paper. The inverse is the opposite. So here's a little example here. If I have a smiley face, if I'm adding to a smiley face, what is the opposite of a smiley face? Well, you're probably saying to yourself a frowny face, but for this purpose, let's put a negative smiley face. That would just be 0. If you have a happy person and a non-happy person, they would cancel each other out and it would just be 0. If we have negative a, well, the opposite or the inverse of negative a would be a. So negative a plus a is 0. Or you could also show it like this. A plus negative a, that also equals 0. Some number examples. Negative 7, the opposite of negative 7 is 7. So negative 7 plus 7 is 0. Or we could have something like this, 4 plus negative 4 in parentheses, those are opposites or inverses. So that would also equal 0. Now the multiplicative inverse, this one's a little bit more, I wouldn't say tricky, but if we have a square, if we multiply that by 1 over the square, that is going to equal 1. So with the multiplicative inverse, whenever we multiply a number times its opposite, it is going to equal 1. So if we have a times 1 over a, that equals 1. And then my number example, if we have 8 times 1 over 8, that would also equal 1. You might have heard of the word reciprocal before. Reciprocal is just opposite fractions. So if we were looking at this number example, you could put a 1 underneath there. And then if you remember how to multiply fractions, 8 times 1 is 8, and 1 times 8 is also 8, so 8 over 8 equals 1. So with the inverse property, we're trying to take the opposites, and if we're adding them together, we want them to equal 0, and if we're multiplying, we want them to equal 1. Last one, the multiplicative property of 0. This is exactly how it sounds, the multiplicative property of 0. Anything times 0 is 0. So star times 0, well, that's 0. A times 0, that's also 0. 17 times 0 is 0. So all the multiplicative property of 0 says is anything times 0 is 0. So that was just a little two-part video series on the notes for properties. I know that was a lot at you at one time, but we will definitely do a little bit more with these as well. So thank you for watching.